I'm going to turn into English now because our next speaker is from Crew. That's what we say in Iceland, Icelandic at least. His name is Justin Hughes and he is head of aluminium and raw material at Hugh. And he is going to describe his scene on the current trends in the aluminium industry. And obviously there has been a lot of turbulence in that sector recently. But Justin, the floor is yours.
So thank you for having me. Quick legal notice I'll put through. These are all the views of Crew, and our forecasts are as good as we can make them, that's for sure. So thanks for having me. I'm going to talk about the aluminium market overview and our 5-year forecast, and go through the demand and supply that we look at CRU. We have about 250 analysts worldwide in a variety of offices in Europe, Middle East, America, India, China and Singapore. And those give us a bottom-up, as we call it, a supply and demand view of the world. And that's how we generate our price forecast and our opinions on what's happening in the market. It has been a volatile time, but there's some really strong stories to come out of the aluminium market in the last year and looking forward. So today we're going to discuss demand, where the demand is coming from. Then we're going to look at where the new demand is coming from over the next 20 years, and that's the move into electric vehicles from combustion engines. Then we're going to be looking at why we should recycle aluminium, how we do it, and the benefits thereof. Then we're going to be looking at hydropowered smelters and their advantage versus coal and gas. Then we're going to be looking at the reaction of the US sanctions, both in Iran, Russia, and in terms of imports into the US and their effect on the aluminium price. And then finally, we're going to be showing you our CRU price forecast for the next 5 years and the risks that are involved in that. So from a demand side, it's a really strong story. It's quite rare to see all regions showing positive growth. Unsurprisingly, Japan, a very mature market, doesn't really see much difference in their aluminium demand year on year. But what's really exciting is in Europe, North America, we're seeing very strong growth, and that's coming from an increase in consumption of material for vehicles primarily. And then in the Middle East and China, again, 4% growth. That is coming from new builds, a new middle class, and that also leaks into India as well. A new middle class means more consumption of goods, whether it's vehicles, packaging, and the machineries and construction to build that infrastructure for that new middle class. So generally, as a world view, we see just under 4% growth, but we do think that might be on the short side, and we might, by the end of this year, be looking at plus 4%. But what about the spread of where that growth is coming from? Again, a fantastic story. It's coming from all sectors. We're going to be looking primarily at construction and vehicles in this particular talk, but it's exciting to see packaging growing as we replace glass and plastic and even paper. Aluminium's got a lot of upside there. And in terms of construction, it's a really positive step away from steel and concrete. So in terms of total demand, these are pretty large numbers. One interesting thing about this chart is if you look at 2000, China was nowhere. We really didn't discuss it. That bull market, that real growth in China has been rapid. And by 2022, we see more than 40 million tons of consumption of aluminium in China. And we're going to be looking at more than 70 million tons of total aluminium demand. Obviously, Europe and North America got hit, as yourselves included, during the great financial crisis, 2008 to around 2010, and demand did drop off in that region, but it was quick to recover as aluminium reset itself as the primary source of growth in the non-ferrous metals. So why do we use aluminium in these particular products, and why is the growth so strong? For packaging, it should be fairly simple. Aluminium can be molded, it can be used as foils. The variety of shapes that you can use with aluminium can sheet, for example, is vast. It hermetically seals the product. It gives you a better long life for that particular product. One thing is fairly obvious, but it's non-toxic, and that's really important as aluminium is used in new markets where perhaps toxicity in the packaging has been quite prevalent. On the construction side, a building such as this is a great example of why we use aluminium. Glass frames. Glass is now the popular way to use in a large office block, and aluminium frames are strong enough and sturdy enough and crack resistant to handle that sort of weight, something that steel really would struggle with. In addition, it's corrosion resistant, and once again, it's LEED standard. It meets all those international standards for health and safety and rigidity. But in terms of transport, it's been a fantastic growth over the last 15 years that's increased transport's percentage of total demand and consumption, essentially, to more than 1/3. So in 2000, 2005, it was just down at 14%. We see it at 38% over the last 5 years, and going forward, that should ease up into around 45% over the next 5 years. Aluminium in cars, if you're not aware, is now used in a variety of different components. Originally, it was in the aluminium alloy wheels, were very popular in the early 2000s. We see it in engine blocks now. An engine block is far lighter, it's far more efficient, it's quieter. That requires less oil. Less friction means less wear and tear. Engines are lasting longer than steel blocks. We're also seeing it in fabricated products such as the bumpers. But we're moving into this exciting time where the entire chassis, the frame, is now being built out of aluminium. A great example of this is a fine British brand, a Jaguar, but now owned by Indian Tata Motors, so we can't really claim it for our own. But this is an exciting vehicle. It's the Jaguar SUV I-Pace, and this is the E-Pace version. So not only does it have an aluminium frame, and a vast majority of the parts are aluminium fabrications, but also it has a battery electric vehicle engine. That's a big change, and unlike many technologies, it only goes in one way. We're only going to see more aluminium used in cars. Alongside this, quite an interesting one, I've seen a few driving around here in Iceland, are the Ford F-150s, the large trucks, the most sold truck in the world. It's an iconic American brand. The new F-150 started production about 2 years ago. It has an aluminium chassis from steel. That's a huge change in the American market. What's been driving that? It's always money. Money drives everything. US requirements for energy efficiency mean that rather than making more efficient engines, they simply lighten the vehicle to get more miles per gallon, therefore coming under the required specifications. That is also what's going to be driving, as we see in a little bit, what's going to be driving the move towards low carbon aluminium. It's normally monetarily driven. So in terms of the move from gasoline, these internal combustion engine vehicles, to hybrid or plug-in electric vehicles, so battery vehicles, it's a very small percentage of the market right now. You'll probably know about Elon Musk's Tesla vehicles. They're on the cutting edge, but you hear a lot about them, but there's not very many of them on the road. The hybrid, such as the Honda Prius, that's more visual, and it's simply because the battery life is not quite there yet for long distance travel and travel outside of cities where there's no charging points. Therefore, at this time, people still rely on an engine to get them through those difficult periods of travel. However, by 2030, we're already seeing a vast amount of hybrid and battery vehicles, well over 1/3. And by 2035, more than half the vehicles on the road will be battery driven. This is a conservative estimate. Technology tends to move very quickly, and it's really difficult to map the pace at which this will come on, but we suspect that this could be 5 years too laggy, so too slow. In terms of aluminium in the car, 100 kilograms of aluminium in terms of weight reduction reduces your carbon emissions by 9 grams per kilometre, a huge amount, and it reduces per 100 kilos the average amount of fuel by 800 litres. So just in terms of weight reduction, there's huge gains, whether it's battery or electric. But in terms of the actual aluminium consumption, there's a vast amount more aluminium going to be used in battery cars, and that's from things like battery housing and additional fabricated products. So you can see a normal car is nearly all casts, but we're going to get a much better spread for rolling and extruded products as we head into full battery vehicles. This is just a good representation of what's happened in China. and the potentially interesting situation for scrap, car scrap going forward. Chinese roads, I don't know if you've ever looked on YouTube or seen some of these pictures of a Chinese traffic jam outside the major cities in Beijing, Shanghai, down in Yunnan province or down in Guizhou. They're immense. These are 10-lane highways just chock-a-block with cars. That's a lot of vehicles that will at some point reach the end of their useful life and will need to be scrapped. China's realizing that their power to produce primary aluminium is very expensive. It's time for them to get their act together and start scrapping vehicles. Additionally, as we move into battery-powered vehicles, a vehicle's life, it doesn't have as much used car value. People will happily swap to a battery vehicle earlier than they would to another regular gasoline car. And those gasoline cars will become increasingly expensive because the oil price and the incentive to get you into battery vehicles will be there. So it's going to be much more costly on a daily basis to own a regular gasoline car in the next 10 to 15 years. So why scrap? And what's that scrap process? So from bauxite in the ground being scooped out, that's the original source for aluminium oxide, alumina, that's then refined down, and then that's sent to smelters where primary aluminium is produced. Then it's cast into various products, depending on whether it's going into the packaging industry, consumption, or transport. That material is then used. However, aluminium is very rarely destroyed. It's quite like gold in that respect. Nearly all the gold mined still exists, and if we all popped it in a bowl, remelted it, we'd probably have about 99% of all of that production. Aluminium's not too dissimilar. It's quite hard to destroy it, and it's more a function of how much does it cost to extract it from a scrap basis that stops us taking all of that aluminium back, that useful aluminium. You can see once the end of this project, this life cycle for a product, it heads back to the cast house. It's remelted, but additionally, there's a step that's really missing from here, and it's how do we get that metal back to the cast house? It starts with government initiatives such as recycling bins. You'll see them around here, but also on a household scale, simply outside your house, splitting out your recycling. And then on an industrial scale, charging companies for not recycling, charging companies for industrial waste, charging companies who don't scrap their machines. And actually, there's a real value there. You can sell your second-hand material to scrap dealers now. They used to have to pay to take it away. So scrap demand is booming. It tends to sit within this cast house secondary scrap component, but it's vast. Nearly 35 million tons by 2022. And what's important about this chart, it's not just China. This is the rest of the world. Everyone is involved. Ever since the Kyoto agreements, there's been a big push to reduce your carbon footprint. And to do that, one of the most easy ways to do it is to scrap more and produce less primary to take care of all of the consumption demand and this demand growth. If we do not take care of the scrap side of the business, the demand growth increase will simply run away from us, and there'll be a large gap in the supply and demand. That's a bit loud. So green aluminium. This is, I'm referring to low carbon aluminium. It's low carbon in its production, and it's low carbon in its full life cycle. When I talk about full life cycle, I'm talking about from the point that is extracted in bauxite format out of the ground to the point where it's produced into a product and delivered to a customer. Power is a very large component, the largest, most of the time, of the smelting process. At least 1/3, sometimes as much as a half of the total costs involved. Hydropower is the cheapest form. It takes around 4 metric tons of carbon produced versus ton of aluminium. In China, we can see it as high as 20 metric tons of carbon produced in some regions for a coal-powered smelter. This is a pretty significant difference. In Iceland, there's probably under 2 metric tons of carbon produced on a smelter-by-smelter basis. Why is this important that Iceland has this comparative advantage on a carbon side? Well, green aluminium comes with a premium. You'll often see in large company reports CSR, corporate social responsibility. That means that those companies have a responsibility not just for charity work, but also responsibility for their full value chain of products and the environmental impact it has. A good example of this is Apple. Apple phones, they procure all of their aluminium from China. China, as we can see from here, is a very high carbon polluting environmental smelting scenario. Therefore, Apple have a responsibility to try and actually change their procurement process to purchase low carbon material. It's better from a marketing perspective, but also it is better for their company's corporate social responsibility. So we do see a move towards low carbon producers having a higher demand versus their coal and gas powered rivals. So here you can see an approximate chart of the average smelter carbon, both indirect and direct production. You'll not be surprised that you're down there with Brazil, Norway, Canada, and Russia has quite a bit of hydropower as well. And then on the indirect vast amount from coal and gas, it's a significant component of their overall carbon footprint. But on a cost side, what does it mean for Iceland? Versus Norway, you're approximately the same amount, around $400 per tonne. Versus China, China's $650 to $700 per tonne, with some more than $1,000 per tonne, depending on their region. Why is Canada lower? Why is Canada around $275 per tonne for power? It's to do with the state getting involved with power and captive power smelting. Although these companies are not fully vertically integrated, they do have a real joint venture feel, particularly in the Quebecois region, the French-speaking region of Canada, and that allows for better power deals. In comparison to this, there's about 1.2 million tonnes of idled capacity, smelting capacity in the US. Why has that not come back online? We've got strong aluminium prices. The US are looking to increase production of aluminium. The reason is power. On every single one of those smelters, there is a state power provider who has locked them in to a very expensive captive power contract that they cannot get out of, and the federal government have very little influence, unlike in Canada. So those smelters are struggling to come back online, and that's giving an opportunity to smelters outside of the US to take advantage of their lack of forward movement on those smelter restarts. But essentially, hydropower is very difficult to beat on a power perspective. So what does that leave us in terms of price, our forecast, and what's happened in the last few months? It's been a wild ride, but let's just look back at the last couple of years. Why was the aluminium price so depressed? Well, the Chinese had a chronic issue with overcapacity. They built vast smelters. They ran state-owned enterprise smelters into the ground, heavy on debt, supported by the national government, a communist command economy. Their time horizons were vast, and free credit was handed out on an annual basis to these smelter enterprises. All that additional metal was sold outside of China and essentially crushed the world ex-China price. However, China want to look at making their smelting industry more efficient, so they put a 15% export tax on primary aluminium. They want to increase fabricated products, so rolling, cast house, extrusions, and product manufacturing in China, and then sell that final product. They want to get more out of the Chinese efficiencies. So now China only produces around 1 million tonnes that's exported into the global market. In terms of the pricing, that's moved prices a little bit higher, but we've had extreme price volatility in the last couple of months, and that is a real function of the US and their Treasury extending sanctions and imposing trade tariffs. So if we just look at the tariffs, they're called the Section 232. That's import duty on steel and aluminium. It's not clear yet whether this will be a quota system, a hard quota, where only a certain amount of volume can come into the country, and that's it, or whether it's going to be a soft quota, where a certain amount can come in without the additional duty, and then the rest will pay and excess duty. There's been a lot of exemptions. Essentially, the US is after China, but they've had to hit a lot of different countries, and it's going to create a bit of an uncertainty with trade dynamics, and it's certainly affected the price and regional premiums. US premiums to get metal into the US are now considerably higher than in Europe and Asia, but it's brought up the whole market with this uncertainty. Then we've had the US sanctions on Russia, on oligarchs for aluminium. That's namely Oleg Deripaska, the majority owner of UC Rusal, the second largest producer of aluminium outside of China. The problem there was the US hadn't thought through just how important Rusal were across the value chain for aluminium. They weren't going after UC Rusal, they were going after an oligarch. As such, the price spiked from $2,000 about 6 weeks ago to $2,800. A vast price move, unprecedented. We hadn't seen it before. The market was very unsure if we were going to go through $3,000 or whether we'd see a resolution and come back down to $2,200. As it turned out, there was an extension of these sanctions so that the market could change the dynamics. They could offset where Rusal had contracts. They could move material because international freight carriers were scared about secondary sanctions. They were allowed to pay for dollars and move it through banks. And this period until October will allow the aluminium market to change and probably see Rusal sell some assets. So as such, the price has actually cooled somewhat down to sort of $2,400, $2,450, right in the middle of our two-scenario range. As you can see, the resolution and no resolution has quite a wide range, and we're still not through that. Now we've also seen the US pull out of the Iranian deal. This has moved oil prices higher. This is a positive for hydropower producers. It's going to make it much harder for those who are exposed to the Brent and WTI price to produce at reasonable values. So what can we say about the forward price of aluminium? It's looking really strong. You know, we're looking at $2,500 and above over the next 5 years. We're not looking at any pullback really in the price. And the reasoning is clear. It's a strong demand story. The underlying supply and demand fundamentals will always overpower short-term volatility. In 6 months' time, we may be well over the volatility in the alumina market, triggered by shutdowns at Alunorte in Brazil, and we may be also witnessing the Chinese start their winter heating season and taking care of some more excess capacity. And we'll see that consumption coming through, that strong, nearly 4% consumption growth. We're going to see a rise in aluminium scrap, only 5% of the power required to produce that aluminium scrap versus a primary product. Compare that to glass and paper and plastics, which are between 30 and 60% of the power cost. Aluminium secondary scrap has a huge comparative advantage, and that's also going to help fuel and supply the demand for the EV growth. So as I can say, Iceland is a really strong position. You've got low carbon and you've got high demand for your products. So if you have any more questions or you want to speak to me afterwards, I'll be out there having a coffee. So do come and say hello. Thanks very much.